Alright, for question number 2, what letter did you guys pick?
A.
So I recognize that the 2 is on the outside, right? So if I look back at my previous pages, A is on the outside. A is correct. Question. Oh, it's not on. So this is the A letter. And on the A letter, what are you going to write there on the blank? I wrote vertical dilation. Raise your hand if you got that. Okay. So here's our original function in yellow. And then for our new one, this is g of x. 2 times whatever c of x is. Well, if it's 2 times c of x, I just have to take this row here and multiply it by 2. This is c of x, and I just need to multiply it by 2. So 2 times 0 is 2 times 1, and 2 times 8 is 16. Because I'm graphing here g of x, I need this column and this column. So that gives me the order pair what? 0, 0. Next one. And raise your hand if you got that. Alright, now I'm going to go ahead and graph those. 0, 0 at the origin. 1, 2, pay attention. So that would go 2 boxes, and then I need to go up 1 box. 2, 16, right 4 boxes, up 8 boxes. And if you do it symmetrical about the origin, which we've been learning about, then I'm going to go 2 boxes. No, that one's wrong. 2 boxes, half of a box. No, 1, 2. No, it is that is a full. 2, 16, 2, 16. There's my graph. Not wonderful, but there's my graph. Now, if you think about it, the A values, if you notice, affected my X or the Y's. What changed? Did the X values change?
No.
The Y values change because we already talked about a vertical dilation of factor A affects the Y the Y's. Does that make sense? And if you turn back here, our A value is greater than 1. So it does a stretch. Now you might be asking, why does it stretch like going up? Why does it get skinnier? Remember, think of it as, this is my daughter's arms, this is Hadley. She's like, Dad, pick me up, right? And then when I actually pull up on her arms, she's not strong enough like the gymnast, right? I think those gymnasts who do those 2 rings from the ceiling, you know what I'm talking about? When they hold it like that, they're pretty strong. Most people can't do that. So what happens to her arms is her arms get really up close together, right? She's like holding on for bare life, right? She doesn't really drop, okay? So her arms actually become skinnier. Alright, let's go into the next one. H of x is 1/2 of c of x. So if that helps you, I make a table of values. 0, 1, 2, 0, 1, 8. This is what we've been working with, right? And now I'm going to take half of c of x. Remember, multiplying by 1/2 is the same thing as dividing by 2. Multiplying by 1/2 is the same thing as dividing by 2. Do you see the 1/2? Do you see that there? So if I take c of x and just multiply that by 1/2 or divide by 2, 0 divided by 2 is 1 divided by 2 is 1/2. 8 divided by 2 is 4. So I have 0, 0, 1, 1, 1/2, and 2, 4. Let's go ahead and graph that. What do you think is going to happen to our graph? let's take a look at it. 0, 0, 1, 1/2, so it barely gets there, and then 2, 4. Symmetrical going the other direction, then 1, then up a little bit, so 1, down a little bit, and then 2, 4. 2, 4. It's being vertically compressed. Does that make sense? Do you see what's happening to the pink there? It's being squished there. Alright, let's finish up this problem. I have the original problem c of x, I have g of x, and I have h of x. And they want to know, is it where is it symmetrical? Someone said about the origin, so I'm just going to write origin. Is it symmetrical about the origin? C of x is what color, class? My yellow. G of x? H of x. Class, is C of x symmetrical? Symmetrical about the what? About the origin. You see my pen there? One side and the other side. How about G of x? Yeah, it's symmetrical about the origin. And H of x, pink? Same thing. Now we're going to go ahead and prove it algebraically. Partner A tell partner B, how do you prove a function is even, odd, or neither algebraically?
You replace x with negative x. You replace x with negative x.
Macy, what do we need to do? Echo? Make x negative. Let's write that. Make x negative. So I have g of x equals 2 times c of x. C of x we got from the very top of the problem is what? X cubed. Put that in there. Now we're going to do what Macy said, make x value, even this one, tells me I'm substituting. Every x value we're going to make negative. Class, what's negative x to the third power? Negative x to the third times 2 is what?
Negative 2x.
So if I look at these two problems here, the original problem, and I look at the very end, do you see anything odd? What do you see, class? It's not the original, so it's not even. It's odd, because you started with, it's the opposite of what you started with. Now when I say the word opposite, this might be minus sign, and this might be a non-minus sign, so that would still be odd. So that's where my phrase comes in, odd x. Isn't it odd that it starts with a negative? It's the same thing, but just a negative. Let's go ahead and do h of x. H of x equals 1/2 times c of x. Do the same thing. The c of x is x to the third power. And I'm going to make every x value negative. And when you do that, you get negative 1/2 x to the third power. And if you compare them, class, are those the same? No, it just has a negative sign, therefore the answer is odd. So we've basically just proven the transformation of a cubic function, both algebraically down here and graphically.